Hi everyone, welcome to Machine Learning with Python. This is classification problems which we covered last session. We covered the logistic regression and welcome to Vasava who is going to lead the two more part, that is the gain and what to call the measurements related to lift. Those are the two he is going to cover. So this is a short section, part two, but this is session 8. So with that, I'll hand over to Jaymeet. Jaymeet, go ahead, take over.
Thank you. And hi, everyone. This is machine learning using Python. And this is the module 5, which covers the classification problems. Just a sec. So this is session 8. And today it's a short session, which will be covering on the gain and lift charts. And the concepts will be used that we have previously discussed. Not much of them, but it will be a continuation of that. So now AI is the buzzword, and AI has been also been implemented in a lot of fields. We have a lot of implementation of AI in different manner, in which it assists us or helps us do the task very rapidly in a very efficient manner too. So some of the cases are customer experience, supply chain, human resources, fraud detection, or uh, real-time operations management, risk management, and analytics, and some customer insights for the organization, and pricing and promotion related activities. So so let's just go through a few examples. In customer relationship management, the AI can help us, or ML specifically can help us in predicting customer churn and identifying potential leads, personalizing marketing efforts. Then comes the marketing and sales, segmenting customers for targeted marketing, predicting customer lifetime value, and optimizing pricing strategy. In the finance, for the fraud detection, or for low risk and high risk customers, then depending on that crediting score and risk assessment can be done, and algorithmic trading. Then comes the operation and supply chain, demand forecasting, inventory management, predictive maintenance. In human resources, resume screening, employee retention analysis, and workforce planning. So these are all the common implementations of AI, or more specifically ML, in the businesses and the world around us. So of course, when we are applying ML, we need to assess the model that we are using, or the whole system that we are using. So the classification models have the the measuring manner of accuracy, precision, and recall, and F1 score. Then, which we have discussed in the previous session itself. Then the regression models have mean absolute error and root mean square error. Also, because we calculate the mean squared error, we are able to get the root mean squared error as well. Then comes a R squared test, which indicates the proportion of variance explained by the model. These are all the measuring the accuracy of the model. Then comes the A/B testing, comparing the AI model's performance to a control group. Then canary release, gradually rolling out a new feature version to a small subset of users to ensure the stability before a full deployment of the system is done. So these are not just the measurement of accuracies of a model, but also some of them are techniques that helps us to be effectively deploy something. Like the last 2 points of A/B testing and canary release are techniques which helps us to deploy something in a stable manner or the intended manner that we have. So something same is the gain chart and the lift chart. And the gain chart and the lift chart, they help us to see the model's performance and make better decisions based on the output that they have given to us. So gain chart, it shows the cumulative proportion of the true positive cases as more of the population is included, helping businesses understand how effectively the model captures the positive outcomes. So in a way, you can see gain chart uh, as how better the model is at predicting the positive outcomes. Lifting chart, or sorry, the lift chart compares the model's performance to random selection, indicating how much better the model is at identifying the true positives. So basically in lift chart, what you will be doing is you will have the predictive score and the which is compared with the random guessing. So one of the very popular site, which is Geek for Geeks, how does they uh, define the gain and lift? So gain and lift are two measures that are used to measuring the benefits of using the model and are used in business contexts such as target marketing. It is not just restricted to marketing analysis, it is also be used in other domains such as risk modeling, supply chain analytics, etc. And the gain and lift charts are two approaches used while solving classification problems with imbalanced data sets. So when we talk about the marketing campaigns, if we are uh, marketing for a product, there is only 1% or less uh, interaction for the targeted customers and the customers who actually interact with the campaign. So the organization who is marketing, they want to know how much they have to spend per customer or how much they have to spend on the marketing campaign in order to achieve better and desired results for the customers or getting more customers, retaining more customers and stuff. So how our gain and lift charts are obtained. So first we have to predict the positive outcomes of the logistic regression model that we have made and arrange the observation in decreasing order of predicted probability. Then divide the data sets into deciles, and each decile calculate the number of positives in each decile and a cumulative number of positives up to a decile. So why do we divide it in decile? Basically, we want to see that how much per. So decile is basically dividing the data sets into, let's say, 10. Mm, Not let's say, but we actually divide the data set into 10. So 100% of the data set will be containing 10% of data in the whole 100% segment. And each of those decile will give us the positive outcomes, how much of the positive outcomes are present in each of those deciles. And in the end, we calculate the positive probabilities or the positive outcomes that are given by the model. So in order to know that how much percent of data has to be or data is covered from the data set by the model for the positive outcomes. So you can also have the first 3 to 5 deciles can contain almost more than uh, 50 to 70% of the whole data set of the positive outcomes. So you get the insight that to only target the first 3 to 4 deciles up to the data set's population rather than targeting the whole data set, which in the end also makes it effective in terms of cost. Next is uh, how are gain and lift calculated. So gains formula is cumulative number of positive observations up to decile I and divided by the total number of positive observations in the data. The lift, it's the ratio of a cumulative number of positive observations up to decile I using a particular LR model or logistic regression model to the cumulative number of positive observations up to decile I based on a random model. So gain chart is drawn between gain on the vertical axis and decile on the horizontal axis, whereas a lift chart is between uh, the vertical axis and the corresponding decile on the horizontal axis with the lift on the vertical axis. So we'll be using this data set, which is about a marketing campaign of a Portuguese banking institution. So the data set contains these columns or these variables, and how these variables are, uh, which are these variable types. So age, then job is categorical. So the whole data set is a combination of numeric and categorical data. So job, marital status, education, default, housing loan, personal loan, and whether they subscribed to the marketing campaign of the bank or not. And these are all the categorical data that we'll be converting into dummy variables as well for the use. So also you can see that for category, the job has many categories, the like administration, blue collar entrepreneur, housemaid, retired, self-employed, etc. The categorical data for marital status is married, divorced, single, not divorced. As divorced also means that divorced or widowed. Then comes a housing loan and personal loan, whether they have it or not. It's those are yes or no value, and the same goes for subscribed as well. So when we get the data frame, build the data frame bank DF and print few of the results, and these are how the values seem like. We have the age, job, marital status, education, whether the customer is default or not, balance, housing, personal loans, subscribe to the campaign or not, and what were their response to the previous campaign and the current campaign and stuff. So the information regarding the data set, we have total 4,521 entries, total 11 columns. Out of them, 4 are integer data types, and the 7 of them are object data types. It takes 388.7 plus KB to use the data set. So, of course, when we are using the logistic regression model, we have to build the X features and Y features. We are building the X features and removing the subscribed column, which will become our dependent variable. and those X features will be creating from those X features will be creating the dummy variables from the and name it as encoded bank DF, which will be using as the X feature or as the X or the independent values. And the Y will be using the subscribe and using the map function and only have the X equals to yes values for it in the subscribed bank DF. So building the model using the logic method, and also we will be adding the intercepts value sm.add constant within the parameter value itself, fitting the model with the data, and these are the values that we get. So there are many features, and we would like to have more significant features to be found. So we'll be defining the significant features, get those significant features from this from all the columns that we have used as independent variables. So these are the variables that we get for X, which are the most significant ones. So now X features will be made out of these features. So now we'll be creating the model using those significant variables, and now you can see that these are the results when we print the summary of it. So now we have the model, so we'll be making the predictions. So as we have not used the train test split over here, you can try to practice the train test split and also make the prediction on the test side. So the prediction YDF will be made, which will be containing the values of from the model and the predictions that are actually made and the predicted probabilities from the model, and sorting the data in the descending order. So we get the highest values first, and also watching that also remember that we discussed about making deciles and also distributing the data. How? So we have total 452 uh, records in single decile, so or observations into single single decile. So we'll be making get deciles custom function, and also marking into which decile these positive outcomes belong to, whether they belong to the first, second, third, and so on. So you can see that when we run the function and use it to print the first 10 values, these are the values that we get, as you can see in the snapshot in the bottom right, that an additional value of decile is added, in which and the respect in which the respective observations are falling into. So they are falling in decile 1, as we are only printing the first 10 results. Then calculating the gain on the values that we have gotten. We have the gain. Also will be making two decile and gain in the gain lift DF, or the data frame that we have made. So the gain that is calculated, as you can see, for the positive outcomes from the data set, you can see that the first 5 deciles contain almost 70% of the data. In the gain percentage, you can see that 70.05. So almost 70% of the data is covered in the first 5 deciles itself. So now we can know that how many of them are more likely to subscribe. Plotting the graph for it against the number of deciles, you can see this is how the graph looks for when we visualize it. Now, after calculating the gain, we'll calculate the lift. So we'll be calculating the lift by the formula and that we had for the cumulative number of positive observations up to decile I using the LR model, and by the divided by the observation up to decile I based on the random model. So these are the values that we get for the after gain percentage. We have used the lift as well as an additional column and saved those values of lift. When we visualize the plot, you can see that this is how the plot looks for the when we visualize the lift according to the data that we got and the model's output that we get. So the targeting customers using the model can capture almost 2.4 times the number of subscribers compared to the random model in decile 1. Then this is from the graph, not only using the point, but from the graph you can see that in the decile 1 it almost captures 2.4 times the customers versus a random guessing. Then comes to almost 2 for decile 2, and then so on. So just to summarize this session, I'll be summarizing using the code. So we have introduced this was the introduction to the gain and lift concepts, and we use the Portuguese banking institutions dataset in order to understand this. So let's just quickly look at the code. We read the dataset. This is how the dataset looks like, and a lot of them you can see that default housing loans, personal loans, subscribed. And these are all categorical values that will be needing to convert into dummy variables. This is the info regarding the data set. We have total these many entries. Then we create the independent variables, and these are all the ones. And we remove subscribe for making it a dependent variable. So creating the dummy variables, and that dummy variables, those the DF containing these dummy variables will be used as the independent variable in the model that we use, and also creating the intercept while we use it in the model. So there is the logic model that we get, and these are the probabilities calculated by the model. Then we check for the getting the most significant values. So these are the significant values that we get. So we create the X features using, we'll be creating the next model using only these features. So fitting the model to the data and using the logic model and summary. So this is the summary. Now we will be creating the predictions on the actual Y values and the probability values that are given by the model. And so sorting it in descending order. After sorting it into descending order, we we just quickly check for the number of we divided the data set into 10 parts. So how much so how each decile will be containing 452 observations. So this is only to number the deciles according to the values that we get for and the positive values that we have gotten and from this sorted DF. So we use this get deciles on the sorted DF as just said, and these are the values of the first 10 values. As it's these are the first 10 values, the decile will be one only. Then calculating the gain, implementing the gains formula, and this is the gain percentage that we get. As mentioned before in the slides, that we almost cover 70% of the data in the first 5 deciles itself. So it helps us to target those customers uh, who are more likely to interact with the campaign. Visualizing the gain percentage in this manner, then calculating the lift, we added the lift column and the values that we and that was provided that we get for calculating the lift. And when we visualize the lift, this is how we can see. So the model captures almost 2.4 times for decile 1, for decile 2, and then so on for decile 3. It almost goes for 1.8, around 1.8 or 1.7. Then for decile 4, it's 1.6 and so on. So yeah, this was a quick introduction to the gain and lift charts, and we have used an use case for the Portuguese banking institution in order to understand and gain insights regarding that. So thank you.
Yeah, Jaymeet, thank you for the presentation. I think it was brief and to the point on the lift and the gains. And I will assume these two are the parts of the session that is module 5 and summary. This is session 8207. That is module, it should be 5. Summary of 5.2.
Sorry.
Yeah, 5.2 it is. 5.2, 5.2. Module 5.2 and this is session number 8, of course.
Yeah.
That is, this is 5.2 is fine. So you can say module 5.2 instead of session and put the module as 7. Module 5.2, session 7. Session 8, sorry. So I think we are done with that, and when we place this in the YouTube in our channel, everybody will be able to get it proper. Session 1 to 5. So we are 24 session. This is module 5, part 2, and next time we'll start with module 6, and we'll see what exactly. David, you can. Do you have what is the next coverage idea?
So, it will be regarding the decision trees, and it will be the part of module 5 only. So we
Okay.
will have
So it is
module
part of the module 5. Okay. So it will
5,
be
3, and session 9.
yeah, 5.3 session 9 will be next time. So with that, I think we'll end the call today. It's a holiday here everywhere. So I hope people understand and they can go through the recording when they see the recording in the midnight. Today midnight we'll get all this posted. Both the sessions 5.1, 5.2, 5.3 we'll do it next time later. Okay. Thanks everyone. So with that, Jaymeet, appreciate your time. and take care. We'll
Thanks.
close this. I'll
Same.
stop recording.